All right, so in this particular problem in 1.2, we're looking at using data that we already have in a data display with this predictive linear model. So they've created this mathematical model. It's linear, and linear meaning because it only has a degree of 1, so x to the first power. And so they're saying, okay, so we started in 1980, and now we're in 2010. So we take 2010 and subtract 1980 from there, we should get 30 years. In this particular case, they've told us that x represents the number of years after 1980. So our job is to find p, which is the percent with grade average of a, with, I'm just going to say average and a. All right. And so our job is to take this, and the first part is to plug in and figure out whether or not it's saying that this formula that we have, does the formula underestimate or overestimate the percent displayed in the bar graph? And so we take this, we say p is equal to 4/5, x is our number of years, and then plus 27. Pull out your calculator. I'm going to hit pause when I'm doing this. Pull out your calculator and plug that in. And I found out that at 30 years, the function evaluated at 30 years is equal to 51 students, 51%, excuse me, not students, 51%. All right, so now when we look at this for 2010, right, so that's this guy right here, for 2010, we have a comparison of 49 versus 51. So 49 is from our graph, and 51 is our prediction from the formula. And so let's take a look at this. According to the formula, what percentage of college students had an average of an A in high school? Does this underestimate or overestimate the percentage displayed in the bar graph? So since the bar graph is 49, our prediction came up to 51. I'm going to call that an over prediction by 2%. So I'm going to come here and I'm going to type in a 2 right there. And let's check our answer. Let's see what they tell us. Nice, right? So we were over predicting. The formula over predicted what we actually had in the graph. And so we had that over prediction. Sweet. So now we have another part. So I'm going to clear the screen. So let's go pen, clear screen, back, pen. All right. So now it says if the trends shown by the formula continue, project when 59% of college students will have an average A. So in this case here, P is equal to 59%. And what we're looking for is we're going to find X, which is going to be the number of years. But then we have to convert that to an actual year. So we started in 1980, so we'll have to add that on to 1980. All right. So a little bit of algebra here. Remember our formula is right here. So we say P is equal to 4/5 x plus 27. We know our P, so we plug it in. So I'm just going to do it right here. So we get 59 is equal to 4/5 x plus 27. And we start using our inverse operations. We're going to solve that for x. We're going back to our, kind of like previous algebra experience. So we subtract minus 27, minus 27. We get 59, take away 27. That's going to give us 32 is equal to 4/5 x. Now, the inverse of multiplying is to divide, but we don't divide by fractions. We multiply by the reciprocal. So just as a quick reminder is that if I had 4/5 divided by 4/5, we keep the first fraction, we change the sign. So we keep, that's 4/5. We change it from division to multiplication, and we flip or do the reciprocal of the second one. So that's 5/4. All right, so if on this side we multiply by 5/4, which is the same thing as dividing, if we do it to one side, we have to do it to the other side. And then at that point, you can pull out your calculator, kind of whatever you want to do. But on the right-hand side, the 5's cancel, the 4's cancel, and that leaves me with x is equal to, you pull out your calculator, you take 5/4 times 32, and you find out that it's equal to 40 years. So 40 is this guy right here. But that occurs, so we have 1980 plus our 40 years. And so we'd find out that this would occur in 12 carry. So in 2020. Is that right? Yep. And so we come down here and we type in 2020. Come over here, check our answer, and we got it. So that's what we're going to do. So that's what we can do with linear models is linear models allow us to make future predictions about how long it's going to take when we're moving. Any type of model like this. So it could be linear, it could be quadratic, it could be exponential. So there's lots of different functions that you could come across, but